A very good evening, everyone. I welcome you all to the mentoring cum doubt solving session for Code Heist Week 4. It is a pleasure to announce that the Code Heist Contest 4 was a success, just like the previous ones, with more than 2,500 registrations and 1,500 participants competing for the win. We hope you enjoyed participating in yesterday's event as well. We have created a queries voice channel on our Discord server for doubts or any other issues that you may face during the contest. The link for our Discord server is provided in the chat box and also in the description. Before we begin, we already have 10 sponsors, and I'm happy to announce that we have bagged another sponsor, which is none other than the very well renowned DigitalOcean, a scalable cloud infrastructure provider. Here is some information on DigitalOcean. The QR codes, along with the instructions, will be provided to you on your email IDs from where you can access the benefits. It is a pleasure to introduce Mr. Ariman Jain sir, who is well versed with DSA and has profound knowledge of competitive coding. He is here to help us with the questions and doubts. Ariman sir, you may please proceed.
Hello everyone, I will be your mentor for week 5 session of Code Heist, and I will be here be solving your doubts. So, before starting for each question, if anyone have any specific doubt related to some question, we can tackle that first, and then we can target each question. So there was a doubt which that in I think electricity bill. Uh, uh, Copy paste the question. What is the question? Then I can tackle that first before starting. So, a lot of the people were getting problems in this question, and the question was you have given units and you need to find out what will be the total electricity bill. So you need to find first, first 100 unit will be 60 per unit, next will be 80 per unit, then beyond will be 90 per units. For bill more than 300, a surcharge of 15% added on the excess amount. So this was all right. Everyone figure out how to do this, but the problem is like 50 charge, 50 rupee will be paid no matter what. So on top of everything, a 50 rupee should be added to get the final price. So it will be like if the units were around let me say 450. 450 should 100 yeah 450. So if we will first, it will be 50 plus it will be first 100, the first 100 into 60 paisa, so 60 plus next will be uh, how many remain? It remain 250, 350. So next 300 will be, no, next 200 will be uh, for first 700, first 100 and 300, yeah. So for next it will be into 80 paisa plus next 150 will be 90 paisa. So that will be the total case. I think it will be more than 300, I guess. So uh, 200, I guess it will be more than 300. I'm assuming it's more than 300. So we will plus 15% of top of that. I'm assuming it's more than 300. We will add 15% on top of that because of this last line. So basically, we need to add the 50 rupees. This was the minimum charges we need to be paid by everyone, no matter what were the units used. So this was a small issue a lot of people were facing. So I tackled it first. Let me wait if anyone have doubts. You can ask them. Then I can start with one each questions, main questions. Like I know this question can be solved easily. There were two other questions. Division two question were much simpler today, much simpler this time. The other two questions were, as far I remember, they were leap year, I guess. One was about leap year, another was about finding square root if one array is the square root of another array. So let me see, is am I right? Yeah, you're going to array. Order doesn't matter. So this was the other question. So I think let me just uh, tell both questions like mm, on like from the top, not code it and show, but just show it. So leap year question is simple. We just need to check it is divisible by 4 or not, but not divisible by 100, so that we can check this to find leap year or not. So leap year question are like very simple. It's very standard question. The second question where we need to check the square root. So let me paste the question. Okay, so there's no doubt on the channel. Let me paste this question. Okay, so you're given two arrays. You need to check if two elements are like root of like two arrays root of another. So let me just uh, take example. So the example will be 2, 8, and 7. And let me take 64, 49, and 8. And we just check if this array contains all the root elements of this. This can be easily checked because we can either uh, create a map and store square of each. Like we can store a map that this element exists or not, and we can check if a square of this element is in the map or not using dot counts or something. You can hash map this, or you can simply use two loops and find out if it's the case or not. And I think you can't take repeating elements, so you need to do it -1. Like if you find a match, like let me say there were 2 and 8, right? Sorry, I did something wrong. It should be 4 here. Yep, and there were another 4. There was another 2. So once we find a pair, we need to remove this. So it will be not used for another. So what will be the issue? Like with this 4 and it's 3. So if I will not do this -1 or some other weird number that anyone's so then it will create an issue. Like it will we get a 1 for 2 using this 4, 8, 64, we got 7, 49 if we're using two loops. And for this 2 I'll get as a 4. but this 4 is already used, so I can't yet use it again. So I need to somehow remove it. So if I'm using math, count, I should list the count. If this 4 is present only one time, so I can't yet use it anymore. If we are not using math, we are using two loops, I should do it -1, 0, both should work out. -1 will be the most idle. So like this should be taken care. So element is not counted twice or something. So these like division 2 3 question is simple, so I won't like code it. Let me straight start with, and the leap year question is simple. We just need to check it's divisible by 4. It's not divisible by 100, but it can be divisible by 400. So that's the case. So we can check the leap year this how. So let's start with division 1 question. I see there is no doubt. Okay, there is no doubt. So let me. So the first question was standard question, and the second question was upgraded version of a previous heist question. So let me copy paste both. So the question was Berlin goes to a 2D grid, size n into m, and there were number of blocks. So basically, we have a sorted 2D array, and we need to search an element. But the problem was the grid can be large, so we can't use n square or any other complexity. It should be a less complexity solution. So I think the solution should will be cross checked, test cases, and we will take care of memory also. The people if solved using another with higher complexity will be awarded less points. So this will be taken care. So because there is a requirement as grid can be large, use a fast approach with n% complexity was mentioned. The approach should be n+n complexity. So what can be n plus m complexity solution for this? So let's start with the simplest solution where we have given a 1D array, and the complexity of this will be n for brute force and log n for best approach. So in the brute force, we can simply iterate one by one, check if this is equal to x or not, this is equal to x or not, and simply. But log n, if we know it is sorted, so we can use the like we can take advantage of that. So if we compare like a middle element, 6, let's assume. So 6, let's assume. So it can be either equal to 6, less or outside of 6. How can we say this? So if it's equal to 6, we found the element. If the element is smaller than 6, it will be always be on the left side, because we know it's a sorted element and no element smaller will be ahead. Skip all those elements on the right side and just look in the left side. Another problem is reduce. Another problem is to find x in this small subpart of array. And we can repeat this process, finding middle element, and we can repeat this possible uh, repeat this process to find uh, our element if it's present or not, if it's present. And we are using always doing n by 2 n by 2 n by 2. So we know if we are like dividing by 2, always dividing by 2, the complexity is log n. So we can take advantage of that, and this solution will be done in log n. Let me take this question. So where 2D is r. So let's go one by one. Let me take a sample test case. So okay, so this is the sample test case. Uh, Let me see. Okay, so let me paste in compiler only. Then it will be good. 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 Okay. So the brute force will be taking advantage, not taking any advantage using brute force, just looking into the each element and checking. Should be n square approach, not n square. It will be n into m, where n is the width and sorry, n is m is the width and n is the height of this subarray, I guess. We can say length of breadth also, so it doesn't matter. But basically, the size of the array is n into m. So we will iterate over each element and check if it's not. Another approach can be we can take advantage that each row is sorted, right? It's given that I think it's given somewhere. each ball is in number wise order, both row wise and column wise. Let's assume it's only row wise. We can take advantage of row wise, and we can take advantage of row wise, and we can do this. So one sec, I need to just check one thing. Yeah. So we take advantage of row wise. So we know it's sorted row wise. So we can use, we don't need to look for each element. We can just use our login approach here. So what we can do, we can just check if the element is present in this row or not using a login approach. So now the complexity is reduced by login times. So the now the approach is n log n, not n log n, n log n. Will be n log m, because log m for each row, and there were n rows. So n log m. Now we were using the divide and conquer in each row. What if we can divide the conquer whole grid? What will be the case? So let's see that. So let's see, I'll take the middle element 43, and I check if the element is we will be three cases. The element is shorter than this, smaller than this, greater than this, or is equal to. Equal will always be very simple, we can just return true. But let's say the element is smaller. So if element is smaller, we for sure know it will be not ahead in this row. And if it's not ahead in this row, it will be not ahead and here also, because we know all the elements greater will be ahead. So if the element is smaller, so it will be not ahead this. So we can check a divider array, like we know all the elements above this will be smaller than this, right? 43. We know this. All the element above this, it can be this element also, this element also, but we for sure know the elements above this will be smaller than this. So it can be more also. Let me take a bigger subarray, so then I can like show a better one. Let me take some big subarray. Okay, this should work out. Yeah, this is better. Okay, this is much better. So let's take this test case only. Proper this test case, and we can do. So we will check middle element. So let's assume this is the middle element. So we know if the element is smaller than this, it will be either in this part, which is the upper part. So the all the rows whose I is less than this I, index of this is I comma j. We will take all the rows whose I is I less than I, this I, and we will take all the columns whose index is less than this. So basically this we will check here. So I know we twice, because this part, let me, so 1072, so let's do this answer. Uh, we first take this part, and then we will check this part, this part. Okay, so because we know the element is smaller than this, so we will be checking this small part twice, because it will consist in this side also and in this side also. It doesn't matter. We are two parts, two parts. We're dividing into half. So like one with this. Okay. Now we will check in this first if element is present or not. We will use the same approach. We will find the middle element. We will divide twice, and we will use the same approach that we'll check from the middle element. If the element is smaller, we will divide into this like this, one this half and one this half. If element is greater, it will be just like this but downsized. So it will be first this half and then this half. So we will use this approach, and if we will do it repetitively, it will be if we can find if the element is present or not. So at each level we are doing two searches. One will be this half, another will be this half. One more thing, what was the thing? Wait a second, I just forgot. The complexity. So the complexity will be like for each, like T, N, and M. So like, let me say it's T, N, comma M. So we are doing T, N by 2 plus T, M by 2 plus some X constant. So this will be a recursive equation for this, because we are dividing we are dividing grid by n by 2 rows. First we are searching in that n by 2 rows, we are searching n by 2 rows, then we are searching by in m by 2 columns, and I will do the code comparison and stuff. So this will be a recursive solution, and this can be like let's assume it's n only, the 2D. um, so like the width and height is same, so we can take n, and it will be n by 2, so it will be 2 into n by 2. And if we will solve this recovery solution, so it will be p, the value of p n by 2 is equal to t 2 into t n by 4 plus x, and we will place this value here. So it will be c and v. It will be 4 into tn by 4 and 2x, right? So it will be 3x. So the constant type doesn't matter, so we can just assume it will be something. And basically this recovery solution will give, we will get a value of tn by 4. We will use that, and at least at end we'll get the complexity of t2 and tn. So sorry, n, big O n. So this solution use big O n. So we assume that n plus m was the length of the total, basically n plus m. So let's code this out. Okay. So let me just first take inputs. So for inputs, it will be nothing too great. We will be first just taking and m c and m vector int and sorry v and comma vector int m, the vector for int I is equal to 0, I less than n, I plus plus, for int j is equal to 0, j less than m, j plus plus, c and vi j. So this will be the input here. We will take x as the input, and we will let's make a search. We will do it recursively because it will be much simpler. Okay, because we are doing the same thing twice. So let me make a recursive call search. So void, no, bool search. This will be, I'll make a wrapper function for this, or I can do it without wrapper. Let's do it without wrapper. So vector int, not vector int, vector int. It will be 2D, and I have to do here also vector int int m int m int left int up. Let's give a default value for this, so we don't need to pass it in the start. And there will be one more thing, int x. So this will be a case, right? So this will be a case if like the left thing. So basically there will be two pointers. remove the test case. Let me paste it. Oh shit, what's the problem? Okay, this was the test case, right? There will be two pointers. So one will be storing what will be the what. So basically, there's 2D, so we'll need total 4 pointers. Starting point for I, ending point for I, starting point for J, and ending point for J. So N and M will be the ending point for I and J respectively, and left will be the starting point for I, sorry, J, and up will be the starting point for I. So if up is greater than n, basically up the starting point is greater than n, then we can return false. And similarly, if left is greater than, so let me do it right. So let's make it right only, and this make it bottom. So up, bottom, and left, right. So this, so up should be less than bottom, and left should be less than right. So if both case fails, you will return false. Then we will calculate int m1, which will be L plus right by 2. Similarly,